Okay, I hope oh, I hope we're on. Let me just check. Okay, I think we should be good. Okay, so this is going to be the final push now for GC paper 3 tomorrow. So what I've done again, I've collated a bunch of questions based on obviously stuff that hasn't come up yet, based on paper 1 and paper 2. That usually does. And that's what I've done. So I've collated a bunch of questions. It's actually a bit more than 80 marks worth at 100. But this is the aim of this is going to go over all pretty much all of the type of questions that haven't really come up yet, you know. Obviously, like I said, still revise everything, you know. Um, this will be a really, really good like revision, like crash course, for paper 3. And so hopefully, Sway, at this point in your revision, where well, you're ready for tomorrow, and this should be like you should be able to kind of power through this sort of stuff, right? And that's what I'm going to do. So there's going to be a bit of a quicker pace, sort of revision stream than normal. For two reasons. First of all, also to get my video out, this video out onto my YouTube, so people have enough time to watch it and then go back or do whatever before the exam tomorrow. Um, and B, you should be at the point now. You should be able to do questions fairly quickly, routine. And so hopefully I won't need much explanation, but it'll just be literally it'll be a bit quicker pace than usual. Um, which also means it's less time to watch the stream, right? So it's more efficient. Anyway, I'm gonna stop waffling. So we're actually just gonna jump right in. So question one. First of all, again, these index laws are quite common. We have n to the 3 and n to the 4. So you should know you're going to add the powers to get n to the 7. Okay, so that's 3 add 4. Then for part B, simplify 5np cubed all cubed. So that's then going to be this little power rule here, an to the m, you times the powers. So here we say it's 5 cubed, n cubed, p to the 3 times 3 is 9. Okay, but we know what 5 cubed is. 5 cubed is 5 times 5 times 5, which is 125. So this whole answer becomes 125 n cubed p to the 9. Cool. Part C then. Simplify 32q to the 9 r to the 4 over 4q cubed r. So again, this is you're gonna like if you divide the powers, you're gonna subtract them, right? So firstly, 32. This number 32 divided by 4. 32 over 4 is 8. Then q to the 9 over q to the 3 is going to be q to the 6 because you subtract the powers. 9 minus 3 gets you 6. And then we have r to the 4 divided by r, where r is just r to the 1. So r to the 4 minus 1 is going to be 3. And that will be your answer there. Cool. Okay, question 2. We are given a scatter graph, which information about 12 girls. It shows the age of each girl and the best time for, that they ran 100 meters. Okay. So just given the graph, really. First of all, write down the type of correlation. So the line of best fit then roughly would be like there, with some sort of ruler, obviously, but I can't do it like that. Actually, no. It would be there roughly. Anyway, so if the line is going down, so it's like a negative gradient, it's going to be a negative correlation, right? And generally, as one value goes up, so in this case, time goes up, or the age goes up even. So as age increases, the time decreases, right? So it's a negative correlation. As one variable goes up, the other variable goes down. Okay. So that's what you need to pay attention to. Negative, cool. Then we have said Christina is 11 years old. Her best time to run 100 meters is 12 seconds. The point representing the information be an outlier. Explain why. Okay, well, where does point be? So, we're given she's 11, so it would be there somewhere. And her best time was 12 seconds, so it's going to be there. So it's going to be here, right? That's where the point's going to be. Okay, well, it's an outlier, and hopefully you can see why, because it's quite far away from the other points. And in particular, you could say as it's far away from the line of best fit, because obviously the line of best fit is sort of the average of all the points. So we could say, explain why it's an outlier, and that's because as the point is far away uh, from the line of best fit. Cool. Then Debbie is 15 years old, and Debbie says the scatter diagram shows I should take less than 12 seconds to run 100 meters. Comment what she says. Okay. Okay, 15 years old. Where would that be? It would be here, right? Okay, so she said using the scatter diagram, I can predict she's less than 12 seconds. Well, if we did continue the scatter diagram, it would kind of would be. However, the because of the line of best fit. However, the line of best fit uh only is kind of valid between the range of points. So here, the last point is when the age is like 13.8, right down here. When we go further than that, right, this is called extrapolation, which means you're guessing data or results outside of the range. Um, and actually, big 15 would be outside the range. Hopefully, you can see that. So it's away from all the points. So it is it's extrapolation, which means it would not be reliable. Okay. So the scatter diagram does not show that because then it'd be extrapolation. So it would be extrapolating the let's say the diagram. No, the scatter graph, the graph. Uh, so scatter diagram would be unreliable, or the scatter graph would be unreliable for 15-year-olds. For 15-year-olds. So yeah, that's essentially the sort of point you want to say there. Okay, cool. So I've got a diagram. I did my Spanish reading and listening today. Oh, nice. Hope it went well. Cool. Question 3 then, plans and elevations. So we are given a prism on a centimeter grid. Draw the front elevation and the side. Okay. And we have the scale here. Okay. So let's do the front elevation first. So we would obviously be here, doing shown it. We'd look for here. Well, we're going to see this sort of shape, aren't we, on the front? So really, we're going to need to sketch. We're going to need to sketch this. Okay, or draw it, I guess. So let's pay attention to the dimensions. So it would look like this. Remember. So we're going to be 4 meters across. However, 1 meter is 2 centimeters, so 4 meters would be 8 centimeters. Then up here, well, it's going to correspond to this 2, isn't it? But again, the 2 meters would be 4 centimeters. And then we need to deal with this triangle here. So we kind of need this length here. Well, the length is 2.5. Or I could alternatively say, well, what's the height between here and here, right? What would the height be there? Well, if it's 2 meters, well, it's 2 meters for here. Overall, it's 3.5 meters. So this would be 1.5 meters, right? And therefore that'd be 3 centimeters. Okay, because you double essentially to get to the meters. Okay, then what about here? Well, it's kind of the midpoint, isn't it, really? Because this is 2.5 and that's 2.5. So if the midpoint, if the whole of this is 4, then halfway is going to be 2 meters. Well, then 2 meters is 4 centimeters. So now actually we've got all the ingredients to plot this front elevation. So essentially, you're going to plot this shape with these dimensions. Okay, let's go ahead. Um, So firstly, 8 centimeters. We're going to need 8 boxes. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Cool. Then 4 centimeters straight up. So it's going to be 1, 2, 3, 4. Oh, it's a bit rubbish, that is. 1, 2, 3, 4. Okay, then we need another 3 centimeters up. I'm going to need to draw it down, aren't I? It's going to go off the graph. Let's do it down here. So 1, 2, 3, 4, 5, 6, 7, 8. Then 4 up. 1, 2, 3, 4. Okay, cool. Now we need this little slanted height here. But we know up is 3 and across is 4. Up by 3. 1, 2, 3. 1, 2, 3, 4. So this it's going to be there, right? And then you just connect it with a ruler. Okay, but I don't have a ruler. Likewise, connect it there. And there we go. That should be our front elevation. Okay, cool. Now we need the side elevation. Well, reading was pretty good. The listening exam was horrific. Oh, say goodbye to the 9. You probably, I think a lot of us are just prone to just remember all the mistakes we made rather than all the marks we got. But I would say when I did languages, I absolutely hated the listening as well. I think it's universal that everyone just hates the listening portion. Okay, now we've got the side. So the side elevation is going to be this part here, right? But we've got this bit on top. But we're only going to see the actual top, the height up here. We're not going to see the slanted height. We're just going to see the straight vertical height. So if this is 2 meters, this is going to be 1.5 meters, isn't it? So really what we're going to see is essentially some sort of rectangle, aren't we? And then 2 meters is going to be, well, 2 meters will be 4 centimeters. And then there's this little ridge here. You can see where there's a little crease line here, where we there. And then that'll be a further, 1.5 meters up here to get to the top, from here to here, say. And you can see that again here. So 2 meters minus 3.5 is again 1.5 meters, but 1.5 meters will go to 3 centimeters. And then how far across? Well, it's just going to be 3 centimeters, isn't it? But that would go to 6 centimeters. And then we need to plot that on a graph. So we need 6 across. So it's going to be 1, 2, 3, 4, 5, 6. So let's draw that. And then we need 4. Then we need 7 in total. Up. 1, 2, 3, 4, 5, 6, 7. Then we just connect it. And then we have this little line in between the 4 and the 3 because this represents this little sort of line here. And just let's do that. So 1, 2, 3, 4, and then here. But you don't have to draw that sort of line in the middle. You'd be fine with that, but that's just the exact one. So then that'll be front, and that'll be this side. Cool. To be honest, I'll be lucky if I got more than 10 marks. Oh, everyone found it horrendous. Well, then there you go. If everyone found it bad, then the boundaries will go down. Okay, question 4. Okay, So we're given Sally used a calculator to work out the value of a number y. The answer on a calculator display began in 8.3, completely error interval. So again, this is just the range of values y could be. So we know it's going to be 8.3, and then the calculator display, then it'd be other digits after, right? So you could have, for example, I don't know, 2, 5, 7, 1, 8, 9, 2. But we only consider the first two digits, 8 and 8.3. So we are truncating, which means we're basically just getting rid of all the other digits. So what could the other digits be? What could the next digit be? Well, 3.0, right, could be the smallest one. So 8.3 itself, so 8.30, but just 8.3. But also the last one could be 8.39999 and so on. But the problem is, again, that is an infinite number. We can't physically write that down, right? You could say 3.9 recurring, but that's not, it's not a it's not a number that physically we can write down, So what we can say instead is, well, the number after that would be 8.4. So therefore, if we say 8.4 is the upper bound, then anything less than 8.4 would be y, okay? I noticed that because of that, there's a strict inequality where it has to be strictly less than 8.4. So it's saying any number less than that, like 8.399, that will all fall into y, which makes sense because 8.3 will be the first two digits if you just get rid of it. And that's a strategy, right? Whenever I do think they might ask something like this with an error interval, talking about, oh, there's two digits on the display, what's the error interval? It's literally going to be between 8.3 and then the next one, 8.4. Okay, and you get that by just slashing all the other digits. But yeah, cool. Question 5. A company has to make a large number of boxes. The company has 6 machines. All the machines work at the same rate. When all the machines are working, they can make all the boxes in 9 days. The table gives the number of machines working each day. Okay, and we're given some information. Work out the total number of days to make all the boxes. Okay. So this is sort of like a rate question. Like, we're given, I don't know, 6 machines work at the same rate. What would happen if we changed it to like 5, 4, 3 machines instead? How would that affect the output, the work done? Okay, so with this sort of question, well, we are given that 6 machines would take 9 days, right? So therefore, one machine, uh, well, it's going to be taking 9 times 6, right? Because one machine is going to have 6 times the workload. So that's going to be 54 days. Cool. So we know that's how long one machine takes. Well, okay, well then, we know how many machines are in each day, don't we? So in day 1, it's going to be 3. Then there's 4. Then there's 5 machines. So that will be that will take 13, no, 12 days. Okay. So these will take 12 days, but we know in total they take 54. So therefore days remaining is going to be 54 minus 12. So that's going to be 42 days. But then every other day it's 6 machines. So again, now this 42 left is split between 6 machines. So then 42 divided by 6 to work out the days after. The number of days it takes then would be 7. Okay. Okay. So we know there were 3 days then, 1, 2, 3. And then when there's 6 machines, then we need another 7. So therefore, total days is going to be 3, the first 3 days that we discussed, and then this 7 here. So in total, it'll be 10 days. Okay, so that's the key idea of this sort of question, where you want to work out what one singular worker or one machine does, and then you can easily scale it, right? See how much your 3 machines take, 4 machines, 5 machines, 6 machines take. Okay, but cool. I just emailed my Spanish teacher asking if I can sit in this class during period 3 tomorrow because I can't be bothered to go to English. You still go English? I thought English exams were over. Oh, unless you're doing the A level, maybe. I don't know. But I thought it should be all over now, no? Okay, question 6. We are given a table, information about lengths and their frequency. Okay, frequency table. Cool. We're given a frequency polygon for the information in the table. We'll write down 2 mistakes with the graph, essentially. Okay, so frequency polygon, you essentially plot the midpoint of each interval. So here we have 5 with the frequency. So here we have 15. So that's plotted right. Then let's check this, and then you connect each point with a line. Okay, as the graph shows. So what about the second point? Well, that's 15. Cool. The midpoint there is 15. And its frequency is 20. Cool. Then we have 25, so the midpoint's 25. Yep. And the frequency is 50, so that point is fine. Then we have 35. Well, the next midpoint is 35. And the frequency is 25. Yep. So that point is fine. Then we have this point at 50. Okay, well the midpoint's 45. So that is our first error. That point is the last point is plotted wrong. And it should be 45 and then 5. Okay, it's a frequency 5. Yeah, the last frequency is 5. So it did it at the end point, not the midpoint. It should be there, right? That's where the point should be. Okay, so that's one mistake. Yeah, it's over. Just if we don't go home straight after exams, we can sit in English class and do self-studying. Just looking at my English teacher, mate. uh, oh, oh dear. Okay, so that's one error. Okay, what about the other? Well, the graph looks fine otherwise. So really, the only other thing we can look at really are the axes. Really, is it all labelled right? So 0, 5, 10, 20, 30, 40, 50. And its length, yep. What about frequency? 0, 10, 20, 30, 50. Ooh, hang on. What's going on here? Well, it's jumped from 30 to 50. That's probably another mistake then, I reckon. So then the next mistake would be frequency axis is scaled wrong, particularly between 30 and 50. So I'd say oh, hang on. I think I accidentally turned my mic off. Okay, I think it should be okay now. But yeah, the obviously notice here it's jumped from 30 to 50, so that is wrong. So the 40 uh, uh, is in the wrong place essentially. Right. Okay, cool. So it wasn't really anything to do with frequency polygons. That wasn't really. It's just general graph sketching. But yeah, in general, if you wanted, they ask you for those sort of questions with what's wrong with the graph. Firstly, look at if all the points are plotted correctly. Then if that's fine, then check the axis, right? And maybe there'd be like a missing number, like we just saw. Okay, cool. Question 7. Averages. So yeah, we're measuring the heights of tomato plants and we're given another frequency table. First of all, we'll estimate the mean height. So this will be fairly typical. So what you want to do, well, with a normal mean, you times like the height by the frequency and add them up. But here, we don't have an exact number here. We have a grouped data. So the best way is to consider the midpoint. So the midpoint then is going to be 145. And then we're going to times by the 7. Likewise down here, it'll be 155 times by the 10. 165 times by the 15. 175 times by 19 and 190 times by 9. And then we just compute it all, right? So 145 times 7 be 1015. I can see that immediately. It's going to be 1550. 165 times 15 will get me 2475. 175 times 19 will get me 3325. And then 190 times 9 will get me 1710. Okay, then we add them together like with a normal sort of mean. Okay. So if we add them together, again, you put that into a calculator. So 1015, add 1550, add 2475, add 3325, and then add our original 1710 will get me this number here, 10,075. Okay, cool. So now it's a mean. So remember the mean in general is like the sum, obviously like the frequency times the height over the number of the frequency, the number of plants we have. Okay, so then the mean is going to be, well, the sum we worked out was 10, this number here. But then we need the total frequency. Well, actually, they've been not quite nasty. They're not giving us the total amount of plants. So how can we work that out? Well, we just add all the frequencies together. So if we add them all together, we're going to get 7, add 10, add 15, add 19, add 9 will get us 60. Okay. So therefore the mean will be 10,075 divided by 60. And that'll be 167.9166 blah 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 7. And it says the one decimal place, so it's going to be the 9 here. And therefore the 1 is not less than 5, so it will remain 167.9. And that being centimeters, obviously to one decimal place. Cool. Okay. Then it says explain why your answer to pi is an estimate. And also, as a double check, if you're a bit unsure if your mean is right, it's going to roughly lie in the middle of the data here. So if I have, for example, like 82 for the height, well, that's going to be outside the category. So I've known I've done something wrong. So you can kind of use the answer to guide you a little bit as well, that sort of thing. Anyway, then it says explain what's an estimate. Well, the whole idea, and you should note it by, it will always say estimate the mean. It's because, like we just discussed, we have to take the midpoint because we have no actual definite number. Because the data is grouped, okay, and that's going to be our reasoning. Is the height is grouped, so we do not have exact numbers or exact heights, I should say, to calculate the mean. Okay. And that will be the general. If they ever ask you, we've grouped a table like that. Why it's the estimate or the median or the mean is just an estimate. it is because of the fact the date's grouped. Okay, you might be able to just get away with saying the date's grouped. I'm not too sure how strict the mark scheme will be, but that is what you want to write thereabouts. They could also ask for the median, potentially. I'll go over that quite quickly. But because we know the total is 60, well, the median is half of it, isn't it? So it's going to be 60 over 2, which is then going to be 30. So then we need to find where the 30th frequency would be. So you kind of want to do cumulative frequency in a way. So that'll go to 7, then 10 will go to 17, then this will go to 32. Well, 30 is in between 17 and 32. So the median would be here. Okay. And it will just ask for the class. So you'd write down that interval. Okay. If they ever ask, for example, if the total was 61, and then if they ask for the median or something, obviously you divide by 2, but you'll get decimal. But you can't have half of a frequency. So what you want to do is always add 1, okay? Or add to the number that will give you a whole number. So then 62 over 2 would be 31. So then you consider the 31st frequency. But that's if that comes up. Okay, cool. We're talking of cumulative frequency. Now we're given the cumulative frequency. So that says on the grid opposite, draw the cumulative frequency graph for the information. So firstly, this comes from just adding all of it together. Okay. So for example, here the frequency is 7, then it'd be 17, then 32, like we just did, right? 32, then this would be 51, and then that'd be 60. Okay. But then to plot it, well, really, you start with instead of going for the midpoint, you start with the end point. And you can notice that here because notice it's always the same starting point 20. The only thing that's changing is the end point. So with cumulative frequency this time, you want to plot the end point of the class. And that makes sense, right? Because the last value will be the entire like 80th frequency, right? That the last value between 0 and the last value will have to be the whole amount, right? But yes, so we're gonna first we're gonna plot at 70, and the frequency will be 80. Um, so 70, 80 would be here. Okay, then the next part will be 60, and then we need to plot to 75. So 60 would be, where would it? It would be on this line here. And then 75 would be there. And then we want 50 as 64. So 50 would be on this line here. And 64 would be there. Then 40 would be 48. So that would be here. And then the last one, 30, would be 20 for the frequency. Okay, cool. Okay, now we plotted the points. Now we just need to sketch a line. So it always will start from 1, 0 for the frequency. The class doesn't have to start from 0, but the frequency does, right? Because you're not going to start with like 8 frequency, right? You have to start from nothing. So it'll start from 0. I know you can start from 20 if you want. It doesn't really matter. But essentially, now we're going to connect all the points with a smooth curve. So it's going to look if I can draw. Oh, and this is where I struggle. But we're going to plot all these points with a nice curve. Oh, that doesn't really pass through that point, does it? There we go. It's something like that, right? And then it obviously but there we go. So that's plotted. Then we need to estimate the median. And we just talked about the median. The median is going to be again the 50th data, right? The middle. Well, the total again is 80. So therefore 80 over 2 over is 40 would give the median, right? So we need the 40th frequency, which should be here. And then we just use the graph. Uh, and then we use the graph to then find the relevant age. I think it's age anyway. And it'll be there, okay? And that will be 36, whatever the 36 represents. Age in years, okay? So that'd be 36. Cool. So do expect the community frequency graph. They might ask you to sketch it, they might not. But know how to sketch it anyway, or draw it. And they might ask you to predict some stuff as well. So median will be halfway. Interquartile range will be the difference between the upper quartile, which would be 75%, so 3/4 of the total, and the lower quartile, which would be 1/4 of the total. Um, yeah, and whatever else might throw at you. But the whole idea is the same. You just use the graph, read off the graph, and then get the relevant information. Okay, cool. Okay, question 9. Angles and parallel lines. Okay, I would say I picked kind of the harder questions as well. But again, it's good practice. But we're given this sort of parallelogram, and we're given some angles. We need to find x here. Okay, so the first thing immediately to start off with, what angle can we immediately work out? Well, actually, I noticed we have a triangle here. So I know this angle. So that means angle BDC. That's going to be 180 minus 25 minus 124. Then that's going to be at 31. Okay, and it says give reasons for every stage of your work. So that'll be because angles in a triangle, sum 280. Okay, so what I was going to do there then, 31. Well, I can't really do it work out this angle really because we don't know anything about the combined angle. So what else can we do with it? Okay, but this is where we need to stare at the fact we've got two parallel lines. So we're going to need to use either like corresponding, co-interior, alternate, something like that. And I notice actually this angle here is going to be alternate to this, right? And that'll be also 31 because this little sketch here we've got. Oh, this is what's going on here. This B, that'd be C, that'd be A, and that'd be D. We have 31 here. Therefore, this makes a Z angle, right, which is an alternate angle. So then that'd be 31. Therefore, angle ABD, wouldn't it? That's also going to be 31. As because it is an alternate angle. Okay. Oh, I can't spell angle. There we go. Okay, so that's the sort of thing, right? Over these sort of questions, right? You do need to just be able to visualize and be able to break down the shapes you got. And there'll be a few questions like this. But hopefully you can spot that, right? It's an alternate angle. Okay, well we know this. What else do we know? Um, uh, hmm. Well, actually, I know it's well, it's a parallelogram. So actually, we can also pay attention to the opposite sides. And actually, with parallelogram, the opposite sides will always be equal. So if this is 31, and so this angle, for example, is 31 and 25 here. So the whole angle would be what? Six, 56, right? Therefore, this will also be 25 to give 56 because they will be equal. And then we can work out perhaps this angle here, and therefore this x is on the same line because this is in a triangle. So that will 180 take away these two angles, but give us this one, and then we can get x and subtract 180 from it because it's on the line. Alternatively, we could do the opposite angle, 244, and we could work out this angle here. Well, that angle, which is BAE, that's going to be equal to 124 take away 63, right? And that's then going to be 61. And that's going to be because opposite angles in a parallelogram are equal. Okay, hopefully you can spot that this angle here is opposite. So think about what is that the whole shape in general. So you have parallelogram, forget all the lines. We have a 63, and we have this other angle y. So this is going to be 63 add y, and that angle is 124. So that means y will be 124 take away 63. Okay, which is what we've got here. Okay, but now this is now 61. Well, now we can work out x, can't we? Because now we have a triangle to find x. So therefore, x then is 180. Take away 31, take away 51, 61, sorry. And so that's going to be 88. And that's going because angles in a triangle sum to 180. And there we go. Lovely, lovely jubbly. But yeah, so that's the sort of thing with these questions. If you've got two parallel lines, you're going to need to consider either a co-interior angle, which will form a C shape where they equal 180. They're not the same, but they'll add up to 180. You've got like we just discussed, a Z angle or an alternate angle like this, where they're equal. Or we have some sort of like F shape with the two parallel lines here and here. Where this angle would be the same as this, they're corresponding. Or in general, with two lines that cross, we have vertically opposite angles, which will be the same as well. Okay, so those are the four angles you need to pay attention to on the line, or with two parallel lines anyway. But cool. Question 10 now. So we have said that Jane bought a new car 3 years ago. At the end of the first year, the value of the car decreased by 12.5. Then it decreased by 10% every year after. After 3 years, the value of the car was now this number here. Work out the original value of the car. So this is very common. Reverse percentages. We need to find the original given the percentages and the final. Well, the best way to tackle this again is to just let some x variable, x, some number x, be the original. Then we apply the percentages. Okay, well, how are we going to apply percentages? Well, you can use a multiplier. So the multiplier comes from converting this into a decimal. So if we're decreasing by 12.5, that means we have 87.5% of the amount left, right? So that means we're going to apply 87.5%, which is going to be 0.875 by divided by 100. Because remember, percentage is essentially times by 100. Alternatively, you can be a bit safe with this if you're struggling. Well, if we decrease it by 12.5, well, 100 is the original amount, 100%. Then because it's decreased by, we decrease by 12.5. That will be 80. No, that'd be 87.5, wouldn't it? Yeah, that'd be 87.5. Then you can convert it to a decimal, which should be a multiplier by divided by 100 to get rid of the percentage. So that'd be 0.875. So that's what we're going to do. So the first year, we effectively timed the original amount by 0.875. As we just need to decrease it to 87.5 of the amount. Okay, but that'll be the first year. Then it decreases by 10% every year after. So then we're going to need 90% of all of this. So remember, 90% then is going to be 0.9, and or 100%, and then we decreasing it by 10 will get us to 90. Okay, and then this is our multiplier of 0.9, and this happens for 2 years. So we're then going to type by another 0.9 to decrease it again by 10%. However, that would just be 0.9 squared then, wasn't it? And that'll be the amount after 3 years, wouldn't it? Because we first decrease it by 12.5, then we decrease it by 10% for 2 years. But it said after the third year, then it's this. So we could equate this to 17,010. Well, now we can just solve for x, can't we? Really? So firstly, we'll say x times 0.875. I'm going to simplify this a little bit. Times 0.81 is 17010. Therefore, x then is going to be 17010 over 0.875 times by 0.81. And that's going to get me this number here, a pretty nice number of 24,000, which seems fairly plausible. And that being pounds. And there we go. So that's the value originally. Cool. Question 11. Okay, so we are given a solid cylinder on a horizontal floor. The cylinder has a volume of 12,000 or 1,200, sorry, and a height of 40, which is shown here. The cylinder exerts a force of 90 newtons on the floor. Work out the pressure on the floor, and we're given this formula, obviously. Okay, so we're given force, and we want to work out pressure. Well, we're going to need area as well. Okay, so first I'm just going to say pressure is going to be force. Well, force is 90, isn't it? Over area, but we do not know the area. But we are given some measurements of the cylinder, and we know the cylinder, we know its volume, don't we? Well, we're given the volume. Okay, but we also, what area are we dealing with? Well, if this is on the floor, imagine it'll be this would be stacked. This would be upright, wouldn't it? The cylinder. So it would be this circle on the base that would be interacting with the floor. So whatever part or face of these of a solid like this, uh, what the solid that's interacting with the floor, whatever, that's the area we're interested in. Okay. So we're going to want the area of this circle here at the bottom, but the area is just going to be pi r squared, isn't it? That's the area of a circle. Um, so we need the radius, don't we? But we're not given the radius, but we are given volume and height. Okay, let's work with that then. So the volume of a cylinder is going to be, firstly, pi r squared h, right? It's the area, it's almost like a cross section. So this is a cross section times by the height. Okay, so that's pi r squared h. But we are given the volume and the height, so we can say 1,200 is pi r squared times 40. Therefore, pi r squared is 1,200 over 40, which will be 30. Cool. Okay. Now actually, you could rearrange for r if you wanted to. But we're already good because didn't we say this was the area? But this is the area, isn't it? Pi r squared. These are the same, so we could just substitute 30 into here for the area of, the face. But therefore the area then, which is pi r squared, is going to be just 30. Therefore the pressure is now going to be 90 over 30. So that'll be 3. The units would be, well, force divided by the area, which should be centimeters squared. Okay, but they'll give you the units. But that's the number, right? 3. Cool. So the big thing with this sort of question is to work out the face, the area, the face of the shape of the 3D shape. What you need to work out, and that be in contact with the floor. Okay. Hopefully, you see because the bottom of the cylinder will be touching the floor. Okay, cool. Question 12. We are given a straight line and a point. We need to find an equation that's perpendicular to L and passes through A. Okay, so perpendicular. You remember it's gonna say the gradient is a negative reciprocal. Okay, but we don't. But we need a line to be in y mx plus c for m to be the gradient here. But this is 3y equals 4. So how are we going to get y? Well, we're just going to divide by 3. So that means y would be 4 over 3x, add 7 over 3. But therefore m, the gradient is 4 over 3. So perpendicular gradient is going to be minus 3 over 4. Because we take the reciprocal of 4 over 3, which should be 3 over 4, and then you make a minus. Cool, so therefore y for our line, that's perpendicular, is going to be minus 3 over 4x, add c. This is not c here because it's not passing through the same points, okay? It's just perpendicular. But we need to know a point then to find c, but we know a point, it's a. So we're going to sub 3 minus 5 into the line equation that we just have found here. So therefore then, well, y is minus 5, so minus 5 would be minus 3 over 4. X is 3, add c. So therefore we can simplify it to, well, c is, well, minus 5 is going to be minus 9 over 4, add c. Therefore c is going to be minus 5, add 9 over 4, which is just going to be minus 11 over 4. Well, now we found our missing value m and c, so therefore the equation of the line perpendicular to L and passes through A is going to be minus 3 over 4x minus 11 over 4. Great. Question 13 now. Right, is this the right order? Yeah, 12, 13. Okay, cool. Now we have a capture-recapture question where we tag a sample of something, then we on the next day, then we take another sample to see how many of the tagged birds or whatever arrive. Anyway, so we'll estimate the number of birds. She takes a sample 70 and tags them. Then the next day she captures a sample 60. Then she's tagged and 12 of them are tagged. Okay. So work out an estimate for the number of birds. Okay, so this will always follow the same sort of format. But essentially, the thing is, the big assumption will be that the proportion of birds tagged in a sample will always be the same. So, first of all, well, there are n birds in the sanctuary. We don't know what that is, but that's what we're working out. How many are in the sanctuary? So the proportion of birds tagged is going to be 70 over n, right? Because 70 of those birds in total were tagged. Okay, now we take another sample, and 12 out of 60 were tagged, right? So the proportion of birds tagged to the total amount will be the same, which is where we get this. And now we can solve for n. So we can cross multiply, for example, but we're going to get 12n is going to be 70 times 60, which is going to be 4,200. Therefore, n is just divided by 12, which is going to get us 350. Cool. Then it says write down an assumption you have made. So I did already talk. I just did talk about that just. But the assumption is one okay. So one assumption is, like I said, the proportion of tagged birds to the population. For any sample we take, any sample birds we take, the proportion of birds that are tagged will always be the same. So you can write that down. However, an easy one to memorize, I guess. But another easy assumption, because it is another assumption we made, is well, the tags haven't fell off. The tags haven't been removed from any of the birds. Okay. So the easy assumption is no tags of the birds fell off. Okay. Oh, flew off. Well, okay, flew off, but fell off. Okay. Or removed in some way. Okay. Which again allows us to assume that the amount of birds that were tagged is proportional to how many there are. Okay. And that's what you want to get at. But yeah, cool. Yeah, if they might ask you for an assumption with this sort of question with tags or capture recapture, you can just learn that it will always be the same. Okay, cool. Question 14 now. So we are given an nth term of a sequence, and we're given the second term is -2, and the fourth term is 12. Then we need the sixth term. Okay. But we can't work out the sixth terms because obviously if we plug in any six, which will represent the sixth term, we're just going to get A's and B's. It won't be an actual number. So we're going to need to find A and B. Well, we've got two bits of information here, so I think we can do that. So first of all, second term is -2. So I'm going to first substitute in n is 2 into this nth term here. So that's going to be A of 2 squared and B of 2. Which will be 2 squared is 4, so that's 4a add 2b, and that is given to -2. Okay. Then n is 4, so then a of 4 squared add b of 4. That's going to go to 16a, add 4b, and that will give us 12. Well, if we label this, say, 1 and 2, is this now not a simultaneous equation? I think it is. So I think therefore we can solve for A and B. So you can substitute, but I think the best way here in this instance is to spot well if we double the first equation, we're going to get A to A add 4B is going to be -4 if you just double everything. But then can't we just subtract the second by by this one? So if we substitute, so then we subtract the second one here by this equation. Well, 16a minus 8a will get us 8a. And then 4b minus 4b will go to 0. So we cancel out the b, okay? So then 8a is going to be 12 minus of -4. Well, minus is a positive, so it'd be 12 add 4, which is just going to be 16, okay? Therefore, 8a is 16, so a is going to be 16 over 8, which is going to be 2. So we found A, therefore we just again plug that into any of the equations now. Say the first one here. So therefore 4 lots of 2 add 2b is going to be -2. So that's 8 add 2b is -2. So 2b then is going to be -2 minus 8. So -8 to both sides. It's going to be -10. But therefore b is just -5. So now we found a and b. So remember the nth term was a squared and bn. So therefore the nth term is now 2n squared minus 5n. So therefore the sixth term now, n is 6, is going to be 2 lots of 6 squared minus 5 lots of 6, and you can plug that into the calculator. And that's going to be 42. And there we are. That's the sixth term. Cool. Then we are given the another sequence, and we're given now this is a quadratic one. We need to find the nth term. And again, this happens every year, quadratic sequences. So the strategy is going to be, well, let's list it again first. 0 to 6, 12, 20. Then, like with a linear sequence where you'd consider the difference. So the difference is going to be 2, then 4, then 6, then 8. But then we consider the next difference. So it's going to be 2, 2, and 2. But hopefully you spot that is now the same. Now, this will be the second difference, right? Because that would be the first one. So then 2a, so you can remember the 2 as like the second difference, so 2 lots of a. That's going to be equal to the number here, 2. But therefore a is just going to be 1, right? 2 divided by 2. Okay, cool. Now, the nth term, because it's a quadratic sequence, it's going to look like an squared and bn plus c. But we already know a is 1, so it's just going to be n squared and bn plus c. So now, to find b and c, let's rewrite it again. So 0, 2, 6, 12, and 20. Now what we're going to do is consider the n squared term. So n squared. And then we're just going to, again, plug in values of n. So n is 1. We get 1 squared is 1. 2 of 2 squared is going to be 4. 3 squared is 9. 4 squared is 16. 5 squared, 25. Then we're going to take them away from each other. So 0 minus 1. 0 minus 1 is minus 1. 2 minus 4 is minus 2. 6 minus 9 will be minus 3. Then we're going to get minus 4 and minus 5. Well, then, this is a linear sequence, and it will always be a linear sequence. So therefore, and this will be bn plus c. This is the linear sequence. So then, well, how are we going to work this out? It's a linear term, so let's do what we usually do. So the difference is going to be it's going to be minus 1, right? Because we're subtracting minus 1 each time. So b is going to be minus 1. Then to get c, well, let's go the other way. So this term is going to be adding 1, but that'll be 0. So that means then c would be 0. So therefore, now we know a, b, and c. The nth term is going to be n squared minus n add 0, but that's just nothing. So that is going to be our nth term. Cool. And that'll be the same process every single time, right? Consider the first and the second difference. Find a. Then you take away by the an squared term. So a was 1, so you consider 1n squared, which is n squared. And then you take that away from the original sequence to then get the linear one. And then you find b and c. Cool. Let's continue. Okay, this is where it can start snapping up again now. Okay, so question 15. We are given O and Q, which is this whole sector here. And it's a sector of a circle with radius 11. So immediately I can label that to be, oh god, that's pretty rough. Oh god. I'm going to do it up here. 11, and that'll be 11, 2. Cool. A is a point on ON here, and B is the point on OQ, such that AOB is an equilateral triangle, which is going to be here, right? With side length of 7. So equilateral means that all these sides are the same, right? And all the sides then are going to be 7, 7, and 7. Find the area of the shaded region as a percentage of the area of the sector. So this shaded region over the whole sector. Wow, really? That's because the area of shaded region is just going to be area of sector, the whole sector, minus the triangle area. Okay, well then let's work both of them out because we can work both of them out. So the sector area, so you know it should know the formula is going to be theta, the angle here, over 360 degrees times by pi r squared, and that's going to give us the area. But we know what the radius is. The radius is 11. But theta, we do not know, really. But I think we can work it out. Because this is all an equilateral triangle. So all three angles here, here, and obviously here are all going to be the same. I mean, you know, all the angles add up to 180. So we have an angle x, so 3x is going to be 180. Therefore, a single angle x is going to be 60. Okay. So that angle there is going to be 60 degrees. And that'll be for every equilateral triangle. Every angle is 60. Therefore, theta is 60 here. So then, therefore, the area of sector, we can then say it's going to be 60 over 360 times by pi of r squared, which will be 11 squared. And that's going to give us uh, um, uh, why does it not give me a nice fraction here? I don't know. It says 20 and a sixth of pi. Okay, I can't do anything more of that. I can't convert it to an improper fraction. I don't know why. I have to look into that. But that's the area of the sector. So this is area of sector. Okay, cool. Now we need the area of the triangle. So we need the area of this triangle of 60 of 7, 7, and 7. So the area of triangle, well, it's not a right angle triangle. They're all angles of 60. But how would we work out the area of a non-right angle triangle? And you should remember it's going to be half AB sine C. So you have two lengths and then you have an angle in between. So therefore the area is going to be half times A, which is, they're all 7, right? All the lengths. But then sine C is going to be sine 60. So we can work that out to be this quite ugly number here. 49 root 3 over 4. Okay. Cool. So then for the shaded region, or the area of shaded region, it's going to be the area of the sector we've worked out to be 20 and a sixth pi. Take away the area of the triangle, which is 49 root 3 over 4. And so that will give you a decimal number for sure. But we can write that down. 20 and a sixth pi. Take away 49 root 3 over 4. Would get me 42.13782945. It's best to write all the digits down because we have a rounding error. We need to round at the end. So try and keep the decimals as it is. Okay, so that's the area of the shaded region. Now we want, it's saying to get the percentage of the region as an area of the sector. So therefore the percentage, well, that's going to be 42. This answer we just have 0.137 dot 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 over the area of the sector. Right, it's going to be a proportion of the area of the sector. The area of the sector, remember, was 20 and a sixth pi. So then that's going to be 0.6651, but that's obviously a percentage, so that's going to be 66.5%. And you can times by 100. Okay, that's how you get to there. Cool. So there we are. Look, and that's the one decimal place as well. 1 dp. Cool. So yeah, so I do think they're going to expect you to do that. Work an area of something like this. So yeah, have an area of general sector, like this. But obviously, then you there's going to be some sort of like triangle. With that again. Here. But then we're gonna. Oh, yeah, yeah. Obviously angle here, but we're gonna have some sort of triangle, right? And it might be like a non-right angle triangle. So you're gonna have to use half AB sine C to work out the area of this triangle. So then what you can do then, the area of the sector, take away the whole sector, take away the area of the triangle, but leave us with this desired bit, right? which would be the shaded region here. Okay, so do remember how you can work out a shaded region like this by splitting it into the area of the whole sector, which you should know is this formula here. Take away the area of the triangle, which you might need to use half A, B, sine, C. They did ask in paper for the cosine and the sine rule, but they didn't ask you for the area of a triangle like that. That might come up in paper 3. Half A, B, sine, C might come up in paper 3. And they might link it to sectors, so be careful for a question like this. But yeah, cool. Question 16. Okay, we are told now that 50 people were asked if they speak French or German or Spanish. Of these people, 31 speak French, 2 speak French, German, Spanish, 4 speak French and Spanish but not German, 7 speak German, Spanish, 8 do not speak any language, and all 10 that speak German speak at least another language. And we're given some stuff about people chose at random, work out probability. So probability is involved, right? So again, you might think maybe 3 languages seem more like a three branched probability tree. But you need to consider all the possible overlaps and intersections of people who might speak multiple languages or some combination, which a tree diagram won't do. So this, you're going to have to recognise is going to be a Venn diagram question, okay? That hasn't come up yet, so be careful. They've already asked a lot of probability tree questions, so it'll probably be a Venn diagram. And we have 3 different categories, so we're going to need 3 circles, right, to represent each language. Let's write that a bit better. There we go. Lovely. And then obviously have this box outside to represent all 50 people, and anyone who doesn't speak any language will be outside the box. Okay, so then let's say this is like F for French, G for German, F for Spanish. Okay, now we need to fill in all the overlaps, all the parts of the circles. So again, it's best to work in the middle than work your way out. So work through all the intersections and work your way out. Okay, so firstly, how many speak all 3 languages? Is that given? Uh, yes, it says 2 people speak French, German, and Spanish. So that'd be here in the middle in the triple overlap. Okay, now let's work with the double overlaps with 2 different circles. Okay, firstly, French and Spanish. Does it say anything about French and Spanish? Yes. 4 people speak French and Spanish, but not German. Well, that's going to be exactly 4 then, because the 2 people represent those who speak French and Spanish and German. We need 4 that speak French and Spanish, but not German, so it's going to be 4 here. Okay, then maybe what about German and Spanish? It says 7 people speak German and Spanish. But that's going to be 5 because remember, 2 people already speak German Spanish because if they speak German Spanish and French, by extension, they also speak German. They speak German and Spanish. So that means there's 5 other people who speak German Spanish, but those do not speak French. Okay, cool. So that's 5. Then what about this overlap here, French and German? And if you want, you can kind of tick what you used off. So I ticked this information off. I've used this information. I've used this information. Now I've got these bits left. We're not given anything about those who speak French and German. Not really. So let's see what else we've got. 31 people speak French. Okay, but I need to fill in one of these 2 bits first. Let's leave it there. 8 people do not speak any of the languages. Well, that's telling you out 8 is going to be outside the box. So 8 people do not speak either. Okay, any language. So now we use that. Okay, what about this? All 10 people who speak German speak at least one other language. So, firstly, what that's telling you is everyone who speaks German speaks something else as well. So that means no people speak only German, which is what this represents here. So we can put 0 here. So there's no overlap with any other language. We're saying that they only speak German, but this is saying no people speak German because they all speak a different language. Okay, And then it says 10 people spoke German, spoke another language. So that means all the overlaps with German and the other circles has to add up to 10. But this is 5 and 2, so that already adds up to 7. So this is going to be 3. Okay. So those three overlaps represent the 5, 2, and the 3 represent all those that speak a different language to German. Cool. So we use that really now. Okay, now it says now we only got this left. So 31 people speak French. Wow, that's going to be this overlap of people who only speak French, but those who also speak French and other languages as well. So that means 31 take away 3, take away 2, take away 4 is going to give us the people who only speak French, which will be in this circle, part of the circle there. So that will give us 31. Take away 3, take away 2, take away 4 will give us 22. And that'll be there. Okay. Now we only got one bit of information left. But we've used everything now. But as that's the only bit of information left, we also know it's kind of like how probability, all the probabilities have to add up to 1. In this case, all the numbers have to add up to the total. The total is 50. So that means 22, add 3, add 2, add 4, add 5, add the 0, which is nothing, add the 8, and then add this bit here is going to be equal to 50, okay? So we can simplify it to 22, add 3, add 2, add 4, add 5, add 8. That'll be 44. Add this missing number x is 50. Therefore, x is 50 take away 44, which would be 6. So this last bit has to be 6. The people who only speak Spanish. Okay, cool. So we filled in everything now. Now we can work out probabilities. That's the whole reason why we do this, right? Okay, what probability are we interested in? 2 of 50 people are chosen at random. Find the probability that both only speak Spanish. But firstly, what region is that? It's going to be this number here, isn't it? The 6 represents those that only speak Spanish. So it's going to be 6 out of the total of 50. But that's choosing one person that speaks only Spanish. We choose 2 people. So if one person speaks only Spanish, then that means there's 5 left. And that means there's only now 49 people left in total. It's kind of like taking one person out of the mix, right? So one person who speaks Spanish is taken out of the mix. So that means we're left with 5 left and then a total of 49. So that'd be your probability. It's like a tree diagram, right? In a weird way. But then that will be 6 over 50 times 5 over 49. But give us this number here, 3 over 245. And that's your probability. You do not need to simplify it, although you can't. But that'd be fine to leave as a fraction. But there we are. Great. Very tricky Venn diagram question, though, that is. But make sure you're prepared. Okay, question 17 now. Firstly, again, make sure you're for part A. Make sure you know how to do a question like this. If we are given an equation and you want to show there's a solution between 2 points, 1 and 2 here, what you need to do is substitute 1 and 2 in to see if there's a sign change. But we want to solve an equation equal to 0. But here, x cubed at x is equal to 7. So we're going to need to rearrange. So x cubed at x minus 7 equals 0. It equals 0. Now we can substitute it in. So we're going to say sub x is 1. That means 1 cubed add 1 minus 7. That's going to be minus 5. Okay. And then we're going to sub x is 2. So that'd be 2 cubed add 2 minus 7. That's going to be 8 to 10 minus, that'd be 3. Notice how now we've gone from negative to a positive. There's a sign change between those two values. Therefore, there is a solution. Okay, and that's what you need to write. There's a solution between x is 1 and 2. Okay. Cool. And then part B says, show that the equation can be rearranged to this. Okay, so notice we cube rooting. So I'm probably going to need x cubed into something, which then I can cube to get just x to cube root. Okay, so then x cubed is going to be 7 minus x. Therefore, x is then going to just be the cube root of 7 minus x, which is exactly what they've got. Okay, it's only one mark, not much you need to do there, but there we are. Lovely. Okay, then we are saying we're starting from x is 2, x0 is 2. Use the iteration formula 3 times to find an estimate. So, well, firstly, the first estimate, x1 is going to be cube root of 7 minus x0. That's going to be cube root of 7 minus 2, because x0 is 2. And that will be this number here, 1.70997597. You have to just write it all down. Therefore, x2, we're just going to reuse the formula then. So then we're going to say the cube root of 7 minus your previous answer. Okay, so then that's going to be 1.7424188802. Then the next estimate will be 1.73884956 by plugging x2 into here now. And we used it 3 times because we got x3. So that is the estimate. 1.73884956, and that is a 6. Cool, there we go, nice. Quick and easy. Question 18 now. Show that this nasty little fraction here, this whole thing simplifies to this. So, firstly, let's ignore what's going on outside the 6. Let's then just focus inside here. So, x plus 5 divided by x squared add 3x minus 10 over x minus 1. So, because this is algebraic fractions, the best solution, the thing you should always be thinking of is always trying to factorize whenever you can. So here I have a quadratic, so I think that might simplify. Let's have a check. So 10, well, the factors are 10, 1, and then 5 and 2. Well, this is going to add somehow to get me 3, isn't it? Okay. Well, I think if we take x is 5, positive 5, and negative 2, that will add to give 3 and time to give minus 10. So therefore, we'll say x plus 5 and x minus 2 is the factor. Okay. And then you could expand it out if you wanted to test it, but that should be right. So therefore, this then becomes x plus 5 divided by x plus 5, x minus 2, over x minus 1. Cool. Now I need to divide this fraction. So remember your KFC, so you keep the first bit, then you change the sign to the times, and then you flip. There we go. And then okay. Oh dear. Okay, so then we're going to times across. So that's going to be x minus 1, x plus 5, all over x plus 5, x minus 2. Now we notice we have a common factor, common thing on both, here and here, right? So that will go to x minus 1 over x minus 2, and we can't do anything more with that. Okay, so that's this whole thing simplified. Now we need to add 6. Okay, so This is basically saying 6 over 1, right? That's a fraction. So we need a common factor of x, denominator of x minus 2. So we're going to add 6 times x minus 2. And then it'll be all over x minus 2. Then I could expand this, right? So it's going to be x minus 1 add 6x minus 6 times 2 is minus 12 over x minus 2. And so we can simplify this, connect like terms to get 6x over x 7x, and then minus 13 over x minus 2. And now, this is now in this form, right? There we go. So I think jobs are good. So that's the whole strategy, right? Is to just try and factorize whenever you can. If you've got a quadratic, like in this sort of question, it's probably going to factorize, right? So make sure you check that, and then you cancel some common stuff out. Cool. Question 19 now. We are given a diagram that looks like some sort of like inverted cone and a cylinder. So what's happening here is grain is being filled into this solid, and we are given some stuff about the units, and it's being filled in a constant rate. Okay, so I'm going to bear that in mind. Rate is a 3, but we're given that. The height is h, we're given that. And we're also given the height of the cone, which is 4. Okay, cool. So it's like after 5 hours, the depth of the grain is 6 meters above the vertex, which is here, the cone. So 6 meters is going to be here, isn't it? It's going to be like up here. So it's going to be 4, and then you got this 2 as well. So that'll give 6 overall. Cool. Okay, then after 9 hours, the container is full, so the whole volume is used up. Work out the value of h, the height. Okay, so I think first of all, let's work out the volume at 5 hours. So volume at 5 hours. Wow, the whole cone, first of all, is going to get filled up, right? The volume of the cone is given here as a third. Pi r squared, now r is 3, so it's going to be 3 squared times h. So the height here of the cone is 4. And so that will be but that's not the whole, that's the height of the cone. But it's also filled up, remember, 2 heights of the cylinder, right? Because it's got up to 6 there. So then we also have the volume of a cylinder when the height is 2, okay, and the radius will be 3. We got this bit added on. So then that's going to look like then the area volume of cylinder. So I'm also going to say V of a cylinder, of a general cylinder, remember, is pi r squared h. Okay, so that's going to be pi r squared. Now the radius of the cylinder will be 3, so 3 squared times h. Now h this time, remember, is 2. Okay, because it's gone 4 in total. It's gone up 6 meters above. So the cone will be 4, and then we have another 2. Okay, just to reiterate. So the total volume of filled after 5 hours would be 30 pi. Cool. Okay. So then after 9 hours, the container is full. So then maybe let's work out the volume at 9 hours. Okay. So then that's going to be, well, it's going to be the whole cylinder and the whole cone, isn't it? Well, the whole cone, again, is its third. Pi r squared. Now the radius of the cone would be 3 squared, and that'd be 4. And the volume of the whole cylinder, so that's going to be pi r squared. Now the radius is 3, but the height is this whole h here, isn't it? So that's h. So that will simplify to 12 pi add 9 pi h. Okay. Cool. But we need to find h. Okay, but we are given this crucial bit of detail. The volume fills at a constant rate. So actually, if the volume, so a constant rate, so if I can work out the volume every hour, I can then work out how much it would be after 9 hours. So, so that I can say volume, so volume after 5 hours is obviously 30 pi. So, therefore, because it's that constant rate, the volume per hour is going to be 30 pi divided by 5, right? Because it's 5 hours that have gone into 30 pi. That would be 6 pi, right? 30 divided by 5 is 6, yes. Well, that's per hour. That's how much it gets filled per hour. So therefore, 9 hours, the volume is going to be 6 pi times 9, isn't it? So that's going to be 54 pi. Well, that's the volume at 9 hours, but this is also the volume at the 9 hours. So I think I can equate them, can't I? And then solve for h. So therefore, 54 pi is 12 pi add 9 pi h. So then I could say 9 pi h, take away 12 pi, both sides is going to be 42 pi. Then I can divide by pi to then say 9h is 42. Therefore, h is simply 42 over 9. Which 14 over 3, which is a nasty decimal. What does it say? Give it as a fraction in the simplest form. Yeah, so that's simplest form, and that'd be centimeters. And there we go. You know what's funny enough with this question, though? This question, if you look here, came from the old spec. Came in 2015, which was the old spec for maths. Because the new spec that you see in now, well, it's not new now, but it first came out 2017. So I find that quite interesting. And yeah, still a tricky question, but they could ask this. I could see it happening. But yeah, so I'd hope, yeah, I'd probably go over. I'd make sure you understand what's going on in this question. Especially aim for the higher grades. Um, but yeah, there we are. Cool. Question 20 now. We have circle theorems. So we're given A, B, and C, four different points on the circle, A, B, and C. We're given a straight line here, and we're given basic efforts measured. BA, we're told, is equal to BD. We can see this because there's a line here. That line means that they're equal in size. And CB here is also equal to CD. So the two dashes represent that equal to the other two dashed line. Okay, cool. We need the size of angle ADE. Apologies. What a day to be busy, to be popular. I'm in demand. Anyway, so if you had a look at this question and what you do, okay, well, they're actually not of what I usually say with these circle theorem questions is work out what you can do straight away. What circle theorem can you do right away? Usually, for example, if they say, "Oh, this is a tangent," you can either use the fact that radius is a tangent to that the radius is perpendicular to the tangent, or the alternate segment, because both of those use the fact we have a tangent, but we have no tangent here. We also have no center, so we can't really do anything with like area at the circumference is half the angle at the center. We can't do anything. It actually quite helped us in a way. We're really restricted in the options we can do. So let's have a look. Well, firstly, it's to do with these angle bits, right, not angle, these lines. Well, is this triangle here not an isosceles? And actually, that means the two base angles here are going to be the same. So if this is x, that's also going to be x. Okay. Um, and the way that works is if you have two in the triangle, two sides that are the same, the angle that's between the two equal sides, then the other two angles are going to be the same. Okay, that's generally how that works. So anyway, that is going to mean that angle 40 at x at x is going to be 180. So therefore, 2x then is going to be 180 take away 40. So that's going to be 140. There we go. But then x then is going to be 140 over 2. So that's going to be 70. So then I can cancel that out to say 70, 70. And I'm going to say this is equal to, so therefore angle, I'm going to give it a name, right? So angle BAD, for instance, is 70. And that's going to be, and it says give a reason for each stage we're working. So that's going to be as triangles isosceles and angles in a triangle add up to 180. Okay, cool. Okay, what else can we do? Well, we can't then work at that angle because it's not exactly on a line because we need that angle. So, by the way, label what angle you want to work out. So ADE, well, it's actually this line here, and I'm going to call that Y. Okay, I would call it X, but we would have used X. So that's 70. Cool. That's Y, but we can't really work out this angle yet. Okay, so let's stare at it, and we are going to have to use a circle theorem, right? Because it is a circle theorem question. We could see that because we've got circle. It looks like a usual question, right? And again, I guess let's rule off what we can't use. So we can't use alternate segment. We can't use angle at circumference. We can't use the tangent radius perpendicular. We have no tangent. There's not really a same segment theorem either. The only one left, I think, is actually the quadrilateral one, where the opposite angles add 180, and we do have it, don't we? This quadrilateral here, oh, A A B, no, that's A, B, C, and D. That's a cyclic quadrilateral because it's 4 points on the circumference, all connected as a quadrilateral. So that is a cyclic quadrilateral. So therefore, uh, well, we know this angle 70, as you can see here. So therefore, this angle is going to be 110, right? So 110 take away 70 equals, no, sorry, 180 take away 70 is 110. So therefore, this angle here, which is BCD, angle And by the way, this line here, this width, it just means angle. Okay, it's short. It's just a notation. So that's going to be 110, and the reason for that's going to be as opposite angles in a cyclic oh, quadrilateral uh, oh, add up to 180. There we go. Now we know that angle, so this angle then 110. What then? This is also another isosceles, isn't it? This triangle here, BCD. So that means again these two base angles have to be equal. So if we're going to call the angle Z, I guess for the instance, that's 110. So these two angles here are going to be Z, Z. So now I'm going to say, well, 100, Z and Z, and this 110 is going to equal 180. So therefore, 2Z is 180 take 110, that'd be 70. Therefore, Z is 70 over 2, which should be 35. Therefore, then, well, Z, let's say angle BDC, right, is 35 because that's all of the angles, right? So BDC is this angle here. Okay, so that's 35 now, as is this. Oh, hang on. Hang on. Is this right? Yeah, that should be fine. Yeah. So what I was doing now was checking the opposite angles add up to unity, and I think they do. So yeah, it should be fine. Anyway, so that should be 35 now. Let me draw it a bit clearer. And that's this angle here. That's BDC, but now we can work out this missing angle Y because now we're on a line here. So therefore, 180 take away the other two angles, 70 and 35, and that's going to give us Y. So therefore, Y is going to be 75. And there we go. That's angle ADE, which they asked us to work out. And the reason for that is going to be as angles. I should have wrote a reason here, so my apologies. Again, that's going to be because it's as isosceles triangle and angles in a triangle sum 280. Okay, and this will be because angles on a line add up to 180. And there we go. There we go. Lovely. Really, so that wasn't really a circle theorem question because it was asking about angles in triangles, isosceles triangles, angles on a line. The only one we used was the cyclic quadrilateral one. Yeah, but I did do more examples in my other revision sessions, which I do recommend checking out if you have the time. I do go over loads more questions like this. But yeah, there we are. Okay, question 21 now. Prove algebraically that the straight line with equation this is a tangent to a circle with equation this. So in general, when you get to this point on the paper, you're going to have to recognize these are actually simultaneous equations. You're going to have to substitute one into the other. So x minus 2y is 10 and x squared and y squared is 20. And the reason for that is going to be is because with any circle, a tangent, so it, it's like for a particular point, obviously the tangent would be like that way. Obviously, you can estimate the gradient and stuff like that, by estimate the grade of the tangent. But the whole point is, say, it hit tangent here, it will only touch the circle once. That is something you just need to know. Um, but that's it, right? So it touches the circle once. So if we have the equation of the tangent and the circle, they will only have one point of intersection. So that will always be true. If there's one intersection only, then it's a tangent. So how are we going to do that? Well, we're going to substitute it in and show we only get one point, one solution, aren't we? These are simultaneous equations. Like I said again, 1 and 2. But now this is a quadratic simultaneous equation because we have a quadratic term involved. So it's a little bit more complicated. But the idea is the same. Now with quadratic, at this point, you never, ever, ever want to really, for GCSE anyway, you never want to eliminate, right? You never want to, because it'd be hard, right? Because in fact, this is a linear term and it's a quadratic. So you're going to want to substitute. Well, the easiest thing to substitute as well, we either rearrange the first equation for x or y. Well, x is easier because x, then we can just simply say, is 10 plus 2y. So then we're going to sub this into equation 2, okay? We can't rearrange the second bit to say x squared is like 20 minus y squared because how are we going to sub that into 1? We have to like square root, but then you have plus or minus. And it's a whole mess, okay? It's an absolute mess. Do not do that. If you ever think about square root and all that, and this sort of question, you've gone wrong. I'm just going to say it. You need to rearrange the linear, and then you can substitute it into the quadratic. Okay, only that way. Anyway, substitute it into 2, so then that's going to be what x is 10 or 2y, and then we square it, because it's x squared here, and then we add the y squared, and that's going to give us 20. And now, this is sort of quadratic, right, but we have to expand it. So 2y at 10 squared is just 2y at 10 times by itself. So then we're going to have to expand it so you can use FOIL. So that's going to be 2y, 2y, 4y squared. 2y times 10 is going to be let's do it down here. 4y squared, add 20y, 2 times 10. Then 10 times 2y is another 20y. And then we have a 10 times 10, which is 100. And that will simplify to 4y squared add 20, 20, 40y add 100. Cool. So then that will give us 4y squared add 40y after expanding add 100 add a y squared. Then I'm going to take away the 20, and so that would be 0. There we are. Because we want a quadratic, so we need to set it to 0. Well, then I can simplify the terms, right? So y squared, 4y squared and another y squared will give us 5y squared. Then 40y, well, it's just 40y. Then we have 100 minus 20 will give us 80. And there we go, we've got a quadratic. Nice. So we need to solve this now. And the way you can solve this is, well, the easiest way, because you've got a calculator, you can just use a quadratic formula. Actually, I think you are given this because you are given a formula sheet, aren't you? But you need to realise it's going to be x is minus b plus or minus square root of b squared minus 4ac over 2a. You just have to remember that. So that corresponds to the coefficients a, b, and c there. So therefore, the solution y, that's going to be minus 40 plus or minus the square root of b's 40 squared minus 4 lots of 5 of 80. Okay, and that'll be 2 lots of 5. And so that will give me, if I put that to the calculator, actually it turns out you just get minus 4, okay? Because that bit will go to 0, the third bit. So I'm left with minus 40 over 2, minus 40 over 10, which would be minus 4. So we only get one solution, which actually is what we wanted. But now we need to find x, right? So we know y is minus 4, so x then. And you want to substitute it into this, what we rearranged at the start, this equation here. Do not substitute it into 2, because then you're going to get x squared is something, then you're going to get plus or minus. And And again, you do not want that. If you have one solution for y, you're going to want one solution for x. So keep it linear, associated to the linear part. So then x then is going to be 10 of 2y. So it's going to be 10 of 2 minus 4, which would get me and that'd be 2. So therefore, one solution to simultaneous equations. Therefore, the line, remember, is tangent to the circle. And that's your reasoning. Okay. Something you need to remember, but you could have kind of worked that out yourself, because hopefully you realise you're going to need to substitute for 5 March. You're probably going to have to substitute it in and solve it like a quadratic simultaneous. Therefore, you spot there's only one solution. Therefore, it has to be a tangent. But that's the sort of thing, right? That's the mechanism for solving a quadratic simultaneous equation. Cool. Question 22. We're given a sketch of a curve y is a cos bx plus c. Okay, so it's a transformation, right? And we need the values of a, b, and c. Oh, okay. So firstly, recognize a, b, and c are transformations, right? So b is stretching the x coordinates and a stretching the y, and then we add in c up. Okay, let's compare with what a cos graph looks like, and it's going to look like this, and you need to remember it. So a normal cos of cos x graph, it's going to go between 1 and minus 1, and that's going to look like this. So this is going to be 90, that's 180, that's going to be 270, and that's going to be 360. Again, it's going to return back to 1 at 360 degrees. Okay, but that's for one whole sort of cycle, right? That's for like one whole hill, if you will. Like here, for example, that's the hill that returns back to its starting point every this returns to the starting point every 360. It has a period of 360. Okay, but here it's something else is going on here. So it starts at 0 and then it returns back to its point at 360 after 1, 2, 3. No, sorry, 1, 2, 3 different like waves, right? But here, remember, it's only one wave. So first of all, we've gone from one wave to 3. That's telling us that the x coordinates are divided by 3. Okay. So in other words, they're squashed down by a third. Okay. Because if they're squashed down by a third, then the curve's going to be a lot more squashed like this, right? Which is kind of what's going on here. Okay. Uh, and we know it's a third exactly because, like we said, we've gone from one like wave to 3 because this is 1, 2, and 3 before it returns, and then it goes back to 360. So it's going to be divided by a third. But how do we represent divided by 3 the x coordinate? Well, in general, say if you have f of x, then if you want to divide by a third, you might well think f of a third x. But with transformations, you need to realise that what you do in the input for x, you do the opposite to what you expect. So here you're not dividing by 3. You're going to times by 3. So actually, if you want to represent divided by a third, that's the same as times it by no divided by 3. Sorry, there we go. So divide by 3 would be a third. Uh, but instead we want to times by 3 because that's the opposite. So actually, it needs to be 3x. Okay, to do the opposite. Uh, t- uh, so we want to divide by 3 to squash the waves down to compress it. Um, so yeah. Um, Instead, you want to times by 3, okay, instead of divide by 3. So that means f of 3 of x, well, cos x will go to cos of 3 of x. Well, isn't that then the b value? So then b is 3. Cool. Okay, now we need to find a and c. Okay, okay, well, A, then, if you think about it, A, so we know B is essentially squashing the x coordinates. So stretching or squashing by a scale factor. So the scale factor here was scale factor of a third, okay, which will correspond to, so x scale factor a third, remember, corresponds to f of 3 of x, because we want to do the opposite. Instead of divided by 3, we want to times by 3. Now, what's going on? The A will represent the kind of the squashing or stretching of y. Okay. Well, the way we can see this is to look at what the difference between the minimum and the maximum is. So here it's between -1 and 3, so the difference is 4. Now, if you look at a normal cos graph, 1 and -1, the difference is actually just 2, isn't it? So we've gone from 2 to 4, so the stretching is 2. So the y scale factor is 2. Um, but then that will correspond to 2f of x, doesn't it? Because that will represent 2 lots of y. So we double the y coordinates. And with y, unlike x, when you change the x part, what you change to the y part outside will do exactly what you expect. So if we want to multiply by 2 to double it, that's exactly what we're going to do. So 2f of x. So that's going to go to 2 cos x, right? But then a is going to be 2 then. And then for c, okay, the last part c. Okay, well, I guess let's look at this initial value y then. So we originally started with 1. Then remember with 1 minus 1. Then we are doubling the y coordinate, so stretching it by scale factor 2. So it's going to go like this, isn't it? So it's going to be between 2 and -2. Um, but this graph goes from 3. So actually, we need to go from 2 to 3. So we're going to shift it up by 1. So that's going to mean f of x add 1. So we're going to add 1 to the y coordinates. And so again, that does exactly what you expect. So you're going to add 1. So f of x is cos x. So it's going to be cos x add 1 to get from 2 to 3. And also this goes from -2 at the bottom here up to -1, which is what we can see here. -1 is the bottom part. So C is going to be 1 then. And that's it. And there we are. That is an absolutely evil question, though, and I picked that for a reason. But again, I'll tell you what, though, you'd thought this would be a hard question from from the past papers. This is again from the old spec, June 2014, which is actually weirdly renowned for being quite an easy set of papers. So I don't know. I think this will be really hard for like a new spec paper. I think a lot of people struggle with this question. But I brought it anyway because I can see them mixing graph transformations with a trig graph. So it's important to know your trig graphs and your graph transformations. But that's a very nasty question. But hopefully this sort of makes sense now. So you just got to realise what each part is doing. So the b of x, so like cos of b of x, is sort of like stretching the x coordinates. So you making the graph closer together or wider apart. In this case, we're making the waves closer together. So we the scale factor be a third, okay? And then the A bit is going to be stretching or shrinking the y coordinates by scale factor A, okay? Um, so that's going to either again widen up this or make it shorter together in the y coordinates in the y axis. And that's your scale factor A. And then C is essentially then you shifting your graph up or down, okay, which we can see here. 2 minus 2 will then have to go to 3 and minus 1, so we shifted it up by 1. Okay, cool. Question 23 now. There's actually only 2 more questions. So we're given A, B, C, D as a quadrilateral. A, B is CD, we've shown that here, because again, we've got these 2 lines. So they both have 2 lines that are equal to each other. And this angle here is equal to this. We need to prove that AC is equal to BD. Okay. Okay, well, we need to prove these are the same. How are we going to do that? I wonder. How are we going to do that? There's not many ways we know how to prove 2 lines are the same like this. We can't use trig or anything like that because we actually don't know any numbers whatsoever. So can't, that's all out the question. So the only way we can kind of prove something like this with angles and lines is congruent triangles. Because congruent triangles, we don't actually need the lengths, we just need to know they're the same. We don't need to calculate anything, so we don't need any actual numbers. So this will be about congruent triangles, okay? Because the idea is, if we have 2 triangles, one that has AC and one has BD, and then they're both the same, then therefore we can then just conclude they have to be the same as well, the length. But then we're going to need 2 triangles. So what we're going to consider, so one of them's going to have to have AC in. So I think it's going to be this triangle here, A, B, and C, with this angle here, and this triangle here, B, C, D, and that'll be the angle. That's not a right angle, bear in mind. We also know that this side is equal to this. So, with congruent triangles, we need to look for common or equal angles and sides. Okay. And firstly, right away, we're given that AB is equal to CD, and that's given. So we already have one side that's common to both triangles. Okay, but we also know an angle. That both these angles are the same as well that were drawn in. They told us these 2 angles are the same as well. So also angle ABC is equal to angle BCD, and that's also given. Okay, so now we only actually need only one piece of one other ingredient. We either need one side or one other angle the same. Because remember, we only need 3 bits, so like SAS or AAS or RHS, but we don't have a right angle triangle. Or SSS, okay. Yeah, so we need one more thing the same. So let's have a look. Well, actually, if I do, so I've already ruled out this angle here. I can't use that again. I can't use this side again because I've already used that. So really, I've either got this side here, BC or AC, or here BD or BC, or one of these angles here. But the angles aren't the same, really. They're not common, except for one line. Oh, do that again. BC is the same on both, isn't it? Because BC is literally on both triangles. Okay. So BC, as we just said, is also common in both. To both triangles. Well, therefore, triangles ABC and BCD are congruent by, well, we've got two angles, the two sides are the same and an angle, so it's going to be SAS, okay, or SSA or anything like that. But two sides and angles are the same, so we can prove it's congruent. So now these two triangles are exactly the same. That's what it means to be congruent. They might just be rotated or a certain way, but all the sides and angles are now the same. So, well, that means, well, clearly this is going to be sort of this. So therefore, AC is going to be equal to BD, simply because this AC corresponds to BD on this triangle. They're the same triangle. They're just rotated a bit differently. Because then if you imagine if we rotated BD by like 180 degrees, it would then look like this triangle, which would be exactly ABC. Okay, so DBC. If you no rotated it anti-clockwise by 90, then you'd get a CBD. But that would be exactly the same as this triangle here. Okay, and then therefore BD then this line would then correspond to AC. Okay. And there we are. There we go. So use congruency to then prove two lines are the same by constructing two different triangles. Cool. So just be aware of that because congruent triangles might come up. They might not explicitly tell you it's congruent triangles, but you kind of need to work it out in the way. Like I said, if we give you absolutely no numbers to work with, again, there's not much you can do. But if you're given angles and sides but no length, so you need to prove stuff are equal, then you're going to probably want congruent triangles. Okay. Anyway, so that's that. Okay, two more. Now we've got a bounds question, and this mixes speed with bounds, which I think will come up because speed and bounds haven't come up yet, and they do like mixing them together. Okay, so we're given a high-speed train has a distance of, I'm going to underline it. It's a number, 487 to 3 hours. Distance is measured in its kilometer, and the time is measured to the nearest minute. By considering bounds, work out the average speed. Okay, so bounds means you need to work out the bounds for the speed, so the upper and the lower bound. Well, we should know that speed is going to be distance over time, which obviously comes from this little triangle here. Distance, speed, and time. If you cover up the speed, you just left with d over t. Okay, cool. Well, the distance is 487, and that's given. It said it's given to the nearest kilometer. So if we want the bounds for speed, we're going to need the bounds for distance and the time. Okay. And it's going to be bounds because if it says something is round to the nearest kilometer or to the nearest anything, that's a rounding. Anytime you have rounding, you're introducing bounds. Okay. Because then what we're going to say is, well, if distance is to the nearest kilometer, well, then what's the next kilometer going to be? It's going to be 488. And then likewise, if you go back, it's going to be 486. So therefore, the bounds are going to be in between these two. So it would be 486.5 and 487.5. So therefore, the bound for speed 487 is going to be 487.5 and 486.5. And then we have time. So now we need time. So again, time is 3 hours. But then it says time is measured to the nearest minute. So we're going to need to give that to a minute. And also our answer needs to be in minutes as well. So we are going to need to convert it to minutes. So you should know that 1 hour is 60 minutes. So that's going to be so the 3 hours is going to be 3 lots of 60 mins. So that's going to be 180 minutes. Okay, but now we need to round that to the time is given to the nearest minute. So to work out the bounds, well, what is the nearest minute? So 180 will then be 8181, and then the next minute after before that's 179. So you consider the nearest minute either way, right? And then again, the bound in the middle is going to be 180.5, and that's going to be 179.5. So then the time of 180 mins, the upper bound is going to be 180.5, and the lower bound is 179.5. Okay, cool. So now we have a bound for distance and time, so therefore we can work out the speed bound. So firstly, the upper bound for speed. So speed UB. Well, we want the upper bound of this division, this fraction. So that's going to be the upper bound for distance over the lower bound, because you want to divide a big number by a small number to get the biggest result possible. Okay, so that's going to be 487.5 over the lower bound for time, which should be 179.5. And then you put that into a calculator, you're going to get this number here. 2 point, I need to make room here. 2.715877,437. And you just need to write all the digits because it's bounds. The decimal points matter, so you're going to need to list it all. So that's the upper bound. Then we're going to need the lower bound. Okay. So the lower bound this time, we want to make the fraction small as possible. So you're going to divide a small number by a big number. So that's going to be the lower distance, which is now 486.5, over the upper bound for time, which is going to be 180.5. So that's going to be this number here, 2.695290,859. Okay, now we have our bounds. Then it says to work out the average speed. So we need an actual number. So if when we have two bounds, the answer is when the two bounds equal each other, because then obviously if the lowest possible value is equal to the highest value, then therefore there's no gap. So therefore, obviously the lowest value is equal to the higher value. Therefore, every value has to be the same. Okay. But how are we going to do that? So we're going to say then the speed overall. So we need an actual value. It's when these two bounds agree with each other. So let's consider the 2 first of all. Well, the 2 is the same. Then let's consider the next digit forward. So it's going to be 0.7 and 0.6. Now these differ. So because they differ now, this is where we're going to stop. We're going to round from here. So the first decimal point. Well, then 2.71 will round to 2.7 for the upper bound, and the lower bound from 2.69 will round up to 2.7. So actually, they both are 2.7 to 1 dp. Okay, and that's going to be because since uh, uh, since the upper and lower bounds are the same to 1 dp. Okay, and that's our answer. Cool. Okay, final question. Okay. What grade do I get? I got a 9. Could you do a more recent paper? I feel like 2017. Yeah. I have done a load of other questions. If you check, I think what might be on my Twitch, but also on my YouTube. I've done a bunch of other sessions like this before with a bunch of papers from the recent ones as well. But the thing is, the topic is mostly the same, right? Uh, So if you get this sort of question, you're going to get the one that comes up. The style hasn't changed that much over the years, to be honest. So this will still be good preparation. And also, I will say I don't have much time now, sadly. I've got 2 questions left, but I won't have time to do a whole paper, sadly. But I will say I've got more resources on my YouTube, because I've uploaded everything onto my YouTube, where you see more questions for paper 3, because I've done more sessions like this. Okay, final question now. We've got vectors. Cool, everyone's favourite topic. So, we are given OAN, an OMB, and APB, which are 3 straight lines. And we're also given AN is 2 lots of OA. So OA is here. So AN is going to be 2 lots of that. Let's keep that in mind. Well, we're given OA is A and OB is going to be B. And so AP, AN, sorry. Well, AN is 2 lots of OA. So that's going to be 2A, isn't it? Okay, we're also given a midpoint M. So that means OM is going to be half B and MB is a half B as well. But we'll deal with that if we need to. Okay. We are given that AP is KAB. That's going to be important because he's going to ask us to find K. Okay, and we're also given that MPN is a straight line. Now, they're not given this to us, but we can add it on. So N to P to N, a really wobbly line. But it's going to look like this, and that's a straight line. Okay, so how are we going to work out AP? Okay, or a value of K. So the strategy of this sort of question, well, we're going to need to consider the vector AP or AB, and then we're probably going to want 2 different ways of getting to AP using the information we're given. Okay, well, AP, first of all, A to P is here, right? So one way I could say I could go from A to N and then N to P. Okay, well, A to N is 2A, and then we have N to P. Okay, so now we're going to need to find some expression for N to P. But we are given this fact that NPN is a straight line. N to P is on NM. So therefore we could say N to P is going to be another multiple T, so multiple lots of NM. Because if we have any vector on a straight line, they're going to be parallel. And remember, 2 vectors x and y parallel if x is some lots of y. Okay, that's what that means. And so, because NP and M on a straight line, then the vectors will be parallel, so we can make multiples. So now this extends to finding NM. So NM is going to be, so N to M, we can go from N to O, and then O to M, right? Well, N to O is going to be, well, overall, that's going to be O to N is 3A. There we go. Because O to A is A, and then A to N is 2A, so 3A in total. But N to O, we're going the opposite way. So if we're going the opposite way, we always subtract. So it's going to be minus 3A to the negative. And then O to M, well, M is a midpoint in OB. So if OB is a bit is 1, so OM is going to be half a B. And therefore we found NM. So therefore NM is now NP is T lots of NM. So it's going to be minus 3 T lots of A and a half T lots of B. So therefore AP, one expression is now going to be 2A minus 3TA and a half TB. Okay, cool. But we're also told this, AP is K lots of AB. Can we find AB? I think we can. So I'm going to call this. So this is one way of getting AP. Another way they're actually given to us, which is quite nice. That also that AP is k lots of AB. But then AB, if we go up the diagram, it's this way, right? It's A to B. Well, A to B, but go from A. You can also go A to O, and then O to B, and A to O. So O to A is A. So therefore, A to O is the opposite direction, so it's going to be minus A, and then O to B is B. So therefore, that's AB. So therefore, we can say that's K lots of A minus A, so it's going to be minus KA, and then K lots of B. And now we've got another expression. Cool. So that's the strategy, right? You're going to want two bits of different ways of finding a particular vector using all the information you're given. Okay, and that's what we've done here. But now we're good because actually it looks nasty, but we have two different equations with two unknowns. So therefore, if AP is obviously the same for these two, we can equate them together, can't we? So therefore, we could say minus KA add KB, this bit here, is going to equal up here 2A minus 3 minus 3TA add a half TB. Yeah, should have copied that right. Yeah, cool. But actually, this is actually a simultaneous equation in disguise because we can compare the A and the B coefficients, right? So firstly, the A bit. So on the left, so we've got minus K for A here. So that's going to be 2 lots of A minus 3T lots of A. And so that's one equation. And then we can compare the B parts. So it's going to be KB. So that's going to be equal to a half TB. So it's going to be half T. Okay, well, these are simultaneous equations, but we can substitute K is a half T into 1. So then we could sub 2 into 1. So then left with minus a half T is going to be 2 minus 3T. And therefore that will solve to, well, I can times by minus 2. So left with T is going to be minus 4 add 6T to get rid of the fraction. I'll show what I did there. I times by minus 2 to both sides. Okay. Cool. So therefore, then I could say 5T is going to be 4. Move that T on the left to the right. And then add 4. So therefore, T is going to be 4/5. Cool. Well, therefore, K then is a half T. So it's going to be half of 4/5. So then that's going to be 2/5. But there we are then. That's our value. K 2/5. That's what it asks us to do. Lovely. There we are. And there we go. There we are. And yeah, just for this as well, but obviously this was from 2017. However, this vectors method is for every single vector question. Even in the most recent ones, you have to do the same sort of thing every single time. You have to, again, form two different a vector. You need to form two different ways of getting there, and you're probably going to need some sort of simultaneous equations by comparing the A and the B parts. The exact method every time. That doesn't change. With the vectors question, for example, doesn't change year on year. So it is still good practice. I would say in general that early papers were harder, but in a way that's better because then if you can ace these questions, then you're better off with the recent papers. Um, cool. So that's all. That's the main questions, right? So if you then practice this stream and then the other stuff I did, obviously do your own bits. So I make sure you cover everything. You revise, but these are like the main questions, like picked from past papers. The questions haven't come up yet. I think you'll be in a good position. in my opinion. And this is the but, the last 3 years now, there has been on one paper every single year for the last few years a nasty circle geometry question, which I'm sure if you've past papers you've seen and you're freaked out over. I cannot sit and say they're not going to do it this year. I can see, for example, them throwing in a circle theorem mixed with perhaps angles of parallel lines, mixed with area or arc of a sector. I can see that sort of thing happening when the merged topics, geometric topics like that together to make a nasty sort of circle question. So, with that in mind, I did go over another one last stream, another sort of nasty circle question to practice. But if you really want to, like, you know what I mean, really cover yourself, get the top grades. I've got the 22 one here. Uh, cool. Can you help me with an exercise? Might be able to, if you could describe it. But I'll let you have a read of this question first, because this is a doozy. This is something else. Okay. But Wilson, I'm not going to be on for much longer though, as well, because I've got to get this video up on my YouTube, because obviously the exam's tomorrow morning, isn't it? So I'm going to give time to upload it, export it, and then obviously enough time for people to watch it or do whatever they want with it before the exam. And if you want those top grades, the grade 9s, I do encourage you to attempt this question. And it does use all the topics we haven't done yet in paper 1 and 2. But I'm not going to explain. I'm not going to give topics away just yet. Okay, let's have a look at this then. Okay. Obviously, pause it or whatever if you want to do it, attempt it by yourself. But let's have a look. Okay. We are given 3 circles with a radius of 3. So A will go to this here, which should be 4. 4, sorry, not 3. Where did I get 3 from? Then B to here will be 4, and here will be 4. I'm going to get rid of that, but I'm going to bear that in mind. Okay. The centres are A, B, and C, such that ABC is a straight line. Okay. And obviously their distance between them is 4, because they're the radii. Work out the area of the shaded region. Okay. Battery's running low. Okay. Let's have a look. Right. Okay. So immediately I noticed they're making a really big thing about the distances between them and the radius. So I am going to have to use that. They're emphasizing that to me. So I'm going to notice that the radius here is going to be 4. And then I'm probably going to need the distance between them is 4, but also the radius is 4. So I think perhaps, well, I'm gonna need to consider the intersections, aren't I? Probably, because that's where the area starts. So that's going to be a radius, isn't it? Because it hits the center to the circumference. So that's going to be 4. But also this is going to be 4 as well, because this the point C is also center, and here it hits the circumference of C, this circle here. So actually, what I've got going on, if I draw it here, B to C, and then let's get rid of this now. And then this intersection point here this is 4, 4, and 4. And so actually, what is this? It's an equilateral triangle. We already covered this, I think, earlier. This is basically, I feel like this is almost an extension from question 15 I did with the sector. But if we know all the lengths, well, then if it's an equilateral, we'll also know all the angles. Again, all the angles are equal, so 3x, if all of them are x. That will add 180, so therefore x is 60. So all of these are going to be 60, 60, and 60. And then why is that going to be useful? We have an angle and we have two radii. What do we know then about that? Well, it's going to be a sector, isn't it? So we're going to, and that will help because area inside a circle could do sector, right? And we know the area of a sector is theta over 60 times pi r squared. That might help potentially because now we have a sector. Okay, let's bear that in mind then. Okay, well, this means if we draw here then and here, that's 4 and 4. That's a radii of 60. That's a sector, isn't it? And so therefore the area of sector, which might help me, that's going to be theta, which is 60 over 360 times pi r squared, where the r is 4, so it's going to be 4 squared. So that's going to be why don't I give me a nice number? No, not a nice number. Nice fact. It's 2 lots of 2/3. So that's going to be 2 times 3 6. Add 2. So that's going to be 8/3, right? A pi. That's what the calculator gives me. Cool. Cool. So that's the area of the sector. So that might help. Okay. Okay. Now I'll consider. Well, actually, what about? Let's get rid of this then now. What if I consider a quarter of the circle here? Oh, that's not the helpful one. Here. Well, it's going to be this section, but also this whole bit here. Right? So then that'd be a quarter. So that'd be a quarter of the circle. But we know what the area of a quarter circle is, don't we? That's going to be pi r squared divided by 4. But we also worked out this sector here, right? We just worked out it was here and here. So the only thing left is this little segment thing here. So we're going to need to work that out. Okay. But also, what if we then did it the other way around? What if we then said we started from B instead? Because remember, that's also going to be 60 that way because it's an equilateral. If we then did it to the same, oh, for God's sake. If we then did it here and then here, worst drawing ever. Again, that would be a sector, but then I'm left with this same segment. And that's going to be the same because of the fact that it's all symmetrical, okay? It's the same angle and the circles are all the same radius. So these two sections are the same. Okay. So therefore, so remember C was, let's go here. C was here, remember, with this segment. And then B would be this way. and here. I think. What do I think? How are we going to work this out? We need the area of this segment, right? Because then it all works out nicely after. But we need to be clever because it's symmetrical. Let's draw the segment again. Let's see what we can do with it. Okay, well, what if we draw this triangle here? That would give the exact same segment part here, wouldn't it? Yeah, that would give the segment here, wouldn't it? Because then that would be the same sector from B that side. That'd be 60. That'd be 60. That segment here will correspond to this segment here. So what I'm saying is with that, then if we have the segment here from here, the whole segment, that's sector, sorry, that's what we just worked out. But then what if you consider the triangle which is formed from here to here? Then if we work up the area of the whole sector, take out this area of the triangle, I'm left with this segment bit at the end. So therefore, so then the area of the triangle, which is going to be 4 by 4 by 4, and then angle 60, that's going to be half AB sine C. So it's going to be half of 4 times 4 of sine 60. So then that's going to be 4 root 3 and a calculator. Okay, cool. So therefore, the area of a segment, which looks like this weird like slice of orange, here, right, in between the edge of the circle and the triangle. So it looks a bit like this, right? So that's going to be the area of the sector, because I'm going to illustrate it once more. The sector we get through this, right? Oh, that's the sector. Then the triangle, we do it like this. Then the segment left is this bit here. So we take away the whole sector, take away the triangle. So that's going to be 8 over 3 pi. Take away 4 root 3. However, we can't compute that because that gives a decimal. We need an exact answer. We need it in terms of pi. So we're going to have to leave that there. So that's the area of the segment. Okay, cool. So now that goes back to what I said earlier of what if we consider a quarter of the circle here? Well, that's going to be the whole area of this, add the shaded region. But now we know what this area is, the whole white bit, right? Because remember, that going to be the area of the sector, add the area of the segment. So the area of a quarter of a circle, so area of a quarter circle, that's going to be shaded region, add the area of a sector, which is going to be 8 over 3 pi, add the area of a segment, okay? So that's going to be this plus 8 root 3, take away 4 root 3, okay? But we know what the area of a quarter circle is. That's going to be pi r squared, where r is 4, remember? So that's 4 squared over 4. So then that's going to be, that would be pi as well, 8 over 3 pi. So that's going to be the shaded region. So I'm just going to say shaded part, right? And particularly this part here. I'm not on about the whole region, we're just on about here. Okay, I'll call that R as well, I guess. I'll call that R to be clear. So the region R. add, I'll just call that R for the region. And then it's going to be 8 over 3 pi, add 8 over 3 pi. That is, what? Why is it just giving me mixed fractions? So it's going to be 5 over third pi. But that's going to be as an improper fraction. That's going to be 5 times 3, 15. That's going to be 16 over 3 pi. Minus 4 root 3. Okay, and so that'll simplify to 4 squared is 16. 16 divided by 4 is 4, so 4 pi is going to be r add 16 over 3 pi minus 4 root 3. Therefore, the region we're interested in, the shaded bit r, is going to be 4 pi, take away 16 over 3 pi, add 4 root 3. So that will be minus, why does it keep giving me a bloody mixed number? 1 of, that'd be minus 4 over 3 pi plus 4 root 3. Okay, cool. Okay, so that's the region, right? So that's the quarter of a circle here. That's this R here. But it's going to be 4 lots of R because it's going to be here as well, R. Then if we continue it down here, R here and R here. So there's 4 shaded bits of R. So the total shaded region, oh, that's going to be 4 lots of R. So it's going to be 4 lots of minus 4 over 3 pi, add 4 root 3. And so that's going to be about 16 root 3, take away 16 over 3 pi. And that, there it is. That's the area, I believe. I'm going to double check that, but I think that should be good. There we go. Man, what a question that is. Uh, Let me just double check that, and then I'll check that question as well. 22. Uh, 16 root 3 minus 16 over 3 pi. Great. Okay, that was right. Lovely. Okay, let me check the question now. But if there is any more, I'll try and help in the meantime. Okay. Oh. Maybe say 4 distinct points on the plane. Okay. For some reason, it's just I can't understand what it's saying in the sense of it's the website's formatted really weirdly. What I'm gonna say is I might try it after, and then at some point in another stream or whatever, uh, I'll try and um, I'll try and look at it, see if I can work out what's going on, because it's just really written really weirdly. Because the symbols are a bit off. But I will say that won't come up on your GCSE. That looks like some sort of really extra sort of question there. But the notation's really weird. So I'll try and look at it and try dissect what exactly it's trying to say because it's a bit weird to me. It looks like it's a French website as well. I don't know. But you have to leave that with me. Try and see if I can get anywhere with it. See, I understand what the question's actually saying. But if there is any more questions though, especially related to GCSE, I'll be here for like the first like a minute or so maybe. But I'm going to head off because it's 9 o'clock, and I'm going to put this on my YouTube ASAP. So anyone for the final run, for the final stretch, they can look at these questions if they need to. Uh, but yeah. Uh, but also I will say the predicted topics will be the not well the predicted but the likely topics that haven't been assessed yet will also be in the description in the YouTube. By the way, the YouTube is linked to my Twitch, and obviously you're watching YouTube, you're on my YouTube, so you're already there. But yeah, so if you want to look at the topics as well, I'm sure like many other people have done a list, but the topics that would like to come up will be in the description. But yeah, it looks like there's nothing else there. I'll try and look at that question again, but the website's formatted really weirdly. I don't know. I'm not going to lie, it looks like some dodgy website. But I'll try and have a look at it. See, but yeah, I am going to leave that there then for now. Good luck on your GCSEs. It's a final maths exam. Good luck on the other ones as well. I might do further maths if you do level 2 further maths. I might try and do. I won't be able to do paper 1, but paper 2. I might do a session for that if I can see the paper. If not, then my prediction revision stream's not going to be very good. But anyway, but as for GCSE, that's it. And maths anyway. That is it. So good luck. But I'm going to leave it here then.